All right. Thank you, God. All right. Cameron Clayton is the CEO of the Weather Company, which is owned by IBM. He's been with the Weather Company for 15 years, and so he's been through a number of changes. But it has only grown. It's basically connected, part of the Watson Group at IBM, so artificial intelligence is a deep, deep part of what you're working on and how you're getting your work done. But, you know, we've talked so much about climate here, and weather is a manifestation of climate. So when you look at where we stand with the climate, what do you see?
Well, I think climate change, for us, we've been covering climate change for 15 years and have a dedicated editorial team that all they do is try and tell climate stories. We actually launched a website called One Degree about 10 years ago just to be dedicated to the climate change topic. And we've learned a lot in that process. I would say one of the key things we've learned is that the science the debate about the science is over. I think you've heard multiple people say that on stage today in different ways. But there's no more debate about the science. It's only what do we do now, right? Is the first thing. The second key thing I'll share, though, like you needed an exclamation point for that, is the coldest summer in the last decade was 2014. 2014 is the hottest year in any recorded history, like up until that point. And it's the coldest in the last decade, right? So every year since 2014 through now has been hotter than the year before. And so it doesn't matter what example we use on the science side, the facts all just line up. On the what do we do about that side is a much harder problem. And I think for our team, we've gone from the shock and awe kind of approach of storytelling to trying to be hopeful. And that's really changed how we have engaged in the climate change debate as a company, as a brand, as storytellers, and it's working. And so, you know, we talk about it all the time, but we talked about it this morning. You know, like Greta is someone who's put the climate change agenda back at the top of the priority list, but has it actually improved or changed the outcomes or the actions or the behaviors that we have?
Well, it certainly changed the public mood. To have, I mean, more people are worried, but you're saying too much worry can lead to paralysis.
Absolutely. We call it the ostrich effect. You get scared and you put your head in the sand and you keep buying SUVs, right? Like that's basically what we're doing as a society. You know, the car companies don't make cars anymore. They just make SUVs. And so, you know, we have to change the dialogue. And I think Greta's done a great job putting it at the top of the agenda. But I don't think anybody, including us, have figured out how to actually turn that into action on a consistent, repeatable way. And I think we're still at that stage where people are looking for a singular answer, right? Like, is it a carbon credit tax or tracking system or something? That's going to be the holy grail for climate change. And it's not. Should we do it? We should do it. But you need like hundreds and hundreds of different things to happen to go forward. Many of those things are simple things that we can do ourselves everywhere we go, but we don't. Right? We choose to drink bottled water because it's convenient. But if we said we don't want bottled water, we want refillable bottles, and actually made the choice to say that and share that with the hotels and restaurants we went to, that would help. It's not going to solve it, but it would help.
Well, so what you're doing, and I know you've really added enormous weather forecasting and explanation capabilities to your work, I don't want to, I hesitate to use the word adaptation because we don't want to adapt, but you are helping people cope with the extreme, the changed, the new, the unpredictable weather that we are experiencing.
Yeah, well, I think most people don't realize that there's sort of like the equivalent of the digital divide in meteorology. We call it the meteorological divide. And so essentially, North America, Japan, Western Europe, those countries, those governments have all invested in this science and satellites and spent a lot of money on infrastructure around the weather ecosystem and protecting their citizens. The reality is the rest of the world has not. So there's this huge disconnect. And many of you have probably seen it as you travel, right? If you literally go on a boat, off the coast of Florida fishing, you go 30 miles off the coast, you basically hit that divide. You run to the Caribbean.
Out of the place where the U.S. is providing the data.
Exactly.
Yeah.
Exactly.
And it's not as good.
And it's not as good. And so we've been struggling as a company with this, as meteorologists and scientists with this for a long time. And it's really two things have led to our ability to be able to provide a solution. So one's the reduction in cost of computing, cloud computing, supercomputing, the material decrease in the cost of that over the last few years has made a huge difference. And so we literally just launched a new global weather model to try and bridge this digital divide. And so literally, if you're a farmer in Kenya, you now have exactly the same quality forecast as a farmer in Kansas. And so that's a really— On your phone, accessible for free, Apple or Google App Store for 3.5 billion people can go and get now, as of last Thursday, the same quality forecast basically the entire world over. And every 2 miles on the planet, ocean, Earth, doesn't matter. We've basically got a global model improving the weather forecast. And so that things like that are making a huge difference in terms of how economies are going to adapt, how people are going to adapt, how small businesses and large businesses adapt, and how governments themselves change their approach as well.
So one of the things you've done is the resolution of the predictability has significantly improved. So when you say every 2 miles, you can basically have a specific different forecast for every 2 square mile, roughly, area on the entire planet. And it used to be quite a bit bigger of an area that was possible for, right?
Yeah, absolutely. So, I share with people all the time, 2 miles is actually a pretty long way if you're trying to predict the future, right? And so on the 5th hole of this golf course, the weather's one thing. Right here, it might be something else. If you live in San Francisco in the Bay Area, that's very true. Within a couple of miles, it can change dramatically. But that's true around the world. There's microclimates, there's all kinds of things that impact that. And so part of it's been, how do we get the resolution to be as fine as possible? And that's important also to solve different problems, right? And so for farmers in a specific field to be able to, drive yield for their crops, et cetera, that's another big problem that we're trying to help solve. You have to have a really high granular, forecast.
So the way you did that was by getting more data sources and putting AI analytics on top of that. Am I right?
Yeah, weather's the original big data problem, right? Machine learning was almost not invented, but certainly improved and became a science, on the topic of weather. And we've seen a huge improvement in the last 3 years with AI and then, hybrid cloud computing come on board. That's really driven, a dramatic step function increase in forecast accuracy around the world.
And this new product, you call it Graph, is that right?
Yeah, the new global model is called Graph. It's global high-resolution atmospheric forecasting. We're scientists. We need a marketer probably to help us with the name. But that's what Graph's called.
And I know food is a huge part of your thinking and your work. You mentioned it briefly before. Talk a little bit more about the work you're doing around food, and obviously the yields of agricultural fields around the world need to go up in order for us to accommodate our challenges. It's going to be even harder with extreme weather and rapid weather shifting. So explain how you can help.
Yeah, I think I'm sort of a sucker for punishment, right? Like I got climate change on one side that we're trying to figure out how to tell the story and model the future 15 days out with, near as close to perfect accuracy. On the other hand, we're trying to figure out how to feed the planet tomorrow, and we can't feed the planet today, right? So in a big picture way, I think we all sort of inherently know this. We don't produce enough food right now for 6 billion people on the planet. Jump forward 5, 10, 15 years, we have to fundamentally change how we interact with agriculture, how we drive yield and productivity in the agricultural space. And so, as IBM, we've looked at that and said, okay, how can we pull all of our capabilities and assets together for agriculture with the goal of ultimately being a piece of the solution around feeding the planet. And so we basically use our weather satellites, our weather data, which is now global, and we're actually able to do moisture 8 inches under the surface of the soil, 2 inches above, 8 inches above, and then 3 feet above. And then we've built basically AI models with Watson for each type of crop that we're trying to grow. So there's a model for corn, a model for wheat, a model for barley, et cetera.
And that moisture analysis is, again, global?
It's global.
So you can kind of say what the moisture is likely to be 2 inches below the soil anywhere on the planet, roughly?
Close, I wouldn't say anywhere, but close.
But that's where you're going.
That's where we're going. That's where we're going.
That's fantastic.
Yeah, and so, essentially we basically built an app. Farmer can identify their field, we heat map, and we actually give them a walking path to walk through their field each morning, and it's different every day. And we ask them to take pictures with their smartphone as they're walking through the field, and we'll then match those images against that model. So let's just say it's a cornfield. It'll take the images, match each leaf against the corpus of all known images of corn, all disease types, et cetera, and it'll give a prescription to that farmer on what they should do for the rest of that day for that field, and maybe don't do anything. The thing that surprised us as we've been rolling this out is overwatering is actually one of the biggest issues we see with farmers out of this.
Particularly in the U.S.
Particularly in the United States is, they're buying the water, so you have to pay for it. They're using too much. That creates disease, reduces yield. And so, that was not a problem we expected. We expected the opposite problem, candidly, going into it. And it's different, each crop type has got a different solution. And it's, I think it's another interesting way that the AI, huge data sets on a global basis are trying to make a small positive dent.
So really, yeah, positive responses, actually conserving resources, using resources more efficiently as a result of the sensing, the data analysis, and the ability to get it out to the public. That's fantastic. And I don't think most people realize how many sensors you guys operate yourselves. Can you talk a little bit about that?
Yeah, so, I acquired Weather Underground 5 or 6 years ago. We have, close to a couple 100,000 personal weather stations in people's backyards and businesses. But then we've gone out and partnered with Airbus and Boeing, and we have sensors on almost all the commercial planes and run the flight operations and meteorology for a lot of the major airlines around the world. Many of your smartphones, your Apple and Samsung and Android devices all have barometric pressure sensors in them as one of the 40-plus sensors in your smartphone. And so with people's permission, we access those barometric pressure sensors. We're starting to instrument, agricultural equipment, John Deere and Mahindra tractors and various other sort of companies like that around the world. And so we've basically built this global weather model to try and future-proof it for the sort of the censored world that we're all embarking and trying to live in.
But it also makes more sense to me than ever that IBM, of all people, bought the weather company, given that Watson and AI is such a critical part of how IBM sees its own future. Because the quantity of data you must be ingesting at any moment is just beyond belief. And how could you possibly deal with that without the most state-of-the-art tools, I guess?
Yeah, no, I think, look, I tell people ask me all the time, what's it been like to be acquired by IBM? And I tell them, look them straight in the eye and say, two magical things happened to us. One is we got access to AI that we never could have afforded sort of on our own. And now we're one of the largest users of Watson's AI capabilities in the world. And two is access to cloud computing. Those two things have been amazing for us, and they've been amazing for all of you. You just don't know it. Your weather forecast has improved dramatically in the last 3 years in terms of an accuracy point of view because of AI and because of we have spending the same, if not more money, for 100% more compute that we have access to. And to give you a sense of the scale of it, most people don't understand these numbers, and so I'll try and make them sort of relatively digestible. But today, it's at least here in San Francisco is a pretty nice day. If you're watching us on a stream, it may not be where you are, but it's a fairly normal day. There's not major severe weather events happening in the world today. And so we'll do about 25 billion data requests just today.
Wow.
So 25 billion devices or people will come to our infrastructure, to our cloud, and say, I want the weather, right? Your car's doing it right now, even if you're not in it, probably. Your house is doing it, your thermostat's doing it, your plane's doing it, your Uber surge pricing is doing it. Like,
wow.
Everybody's doing it. And that's basically the heart of what we do. And we had to build an infrastructure to support that is all running on IBM's cloud, and it's been incredible.
That's amazing. Okay, who has a question or comment in the audience? Anybody's got something they'd like to ask about how we deal with climate and weather forecast? Is there somebody? Okay.
Hi, Paul Stamoulis. Just a quick question. I was curious about just the adoption and take-up as measured by farmers and folks, and how embracive it's been, or if there's resistance where...
Talk a little louder. Put it a little closer.
And if there is resistance, where it might have come from and what's behind that.
Yeah, so you would imagine that the weather company had been in the agricultural space its entire existence. We have actually only just entered about a year ago the agricultural space for a couple of reasons. One, farmers aren't renowned, and I'm a farmer. I grew up in New Zealand on a sheep farm, which is very stereotypical, by the way. But
it sure is.
But it's sort of, yeah, anyway, we'll leave that there. Farmers are not renowned for being like generous financially, right? And big investors in new technology. So the value you had to be able to demonstrate over what they did before to what they could do if they were going to pay for a solution, we felt had to be materially better. This couldn't be a 5 or 10% improvement. It had to be materially better, and it had to be repeatable every day, day in and day out. And so we waited and invested and did a lot of work to get there. We have not had a lot of resistance from farmers themselves. Someone mentioned it earlier. Farmers are actually really good stewards. They really understand, sort of the give and the take, and they're all in it on a multi-generational basis, if they can be. And so we have not met resistance. What we've been surprised at is where the business model drivers are coming from, right? The fertilizer companies, the sugar companies, the banking and insurance industries are really all the ones driving in behind the economics of this and really helping it take off.
Cameron, thank you so much. Really good.
My pleasure.